Unit 4B, Lesson 5, Solve Systems of Equations. We did this earlier in the year with linear equations. So two linear equations, we solved that system. We used substitution, linear combinations, also called elimination, and then we used graphing. Now we're going to solve systems of nonlinear equations. One of them might be a linear equation, the other one's going to be quadratic. So when doing this, we're either going to use the substitution method or graphing method to solve these nonlinear systems. In this first example, we want to use algebraic methods to solve the system of equations. When we talk about algebraic methods, we're going to use substitution rather than linear combinations. Okay? So what I need to do in this example is I'm going to substitute x plus 6 in for y in the other equation. Because I know x plus 6 is equal to y, I can substitute that equal expression into the other equation. So now I have x plus 6 equal to x squared minus 3x plus 1. If I have a quadratic equation, I want to get it in standard form, set one side of the equation equal to 0. So I'm going to subtract x to both sides of the equation, and I'm going to subtract the 6 to both sides of the equation to get this into standard form. At this point, when we want to solve this quadratic equation, we have many different methods we can use. We could try to factor this. We can try to use completing the square. We can use a quadratic formula. At this point, we can use any method to solve for these x values. This one turns out to factor nicely. This quadratic equation factors down into x minus 5 times x plus 1. Then we use the zero product property to set each of these factors equal to 0, so we get x equals 5 and x equals negative 1. Now we're not quite done because we want to solve the system. We want to find the ordered pairs, so we have to plug each of these x values into either of these two equations. It does not matter which equation we plug it into, but we need to find the y value. The linear equation is probably going to be easier to work with. So if I plug 5 in for x, we have y equals 5 plus 6, which is going to get us a y value of 11. And then if I plug in the other x value, which is negative 1 plus 6, good plus sign, we get a y value of 5. So our solutions are going to be the ordered pairs. We have an x value of 5. When I had that x value of 5, my y value was 11. And then we also had an x value of negative 1. And when I had an x value of negative 1, my y value was 5. So these two ordered pairs are the solutions to this nonlinear system of equations. Now to the second example. In this example, we're going to use the graphing method to solve the system of equations. We look at, we have a linear equation and a quadratic, just like the last example, but in this one we have some fractions, we have a negative a value, so it might be a little more complicated if we try to solve this using algebraic methods, using substitution like last time. So we're just going to use Desmos, graph both these equations, then we're looking for where these two equations intersect on the graph. Those are going to be our solutions. So using Desmos, first we graph y equals 1/2 x minus 3, which is the red line. We have a y-intercept of negative 3, a slope of 1/2, so we go up 1 over 2. And then we graph our quadratic equation, which opens upside down, and that's because we have a negative a value. So what we're looking for in the graph is the two intersection points. We have one of our solutions at negative 2, negative 4, and our other solution is going to occur at the ordered pair 7, positive 1/2 or 0.5. So if we would plug these xy ordered pairs into each equation, that would give us a true statement. So when solving nonlinear systems, we can use algebraic methods, the substitution method, or we can use graphing, put them in Desmos, look for the intersection of the two graphs.